So today we're going to use the review document. And after I get questions from the audience, go through the review document, and some I've picked out as representative questions and work through those. And if you think of, we'll start off with any problems you're having individuals. I mean, if you don't have any, then it's fine. As we're moving through the review, if you think of something, then stop me, because I want to be sure and get everybody's problems addressed before I do my rambling routine. Emily's not addressed. All right. So, anybody have any questions, problems with anything in the chapter and the homework? I hope everybody is starting to memorize their symbols, because the next exam is going to go heavy into those symbols. And the sooner you get them memorized, the better off you're going to be. Okay. No specific problems. Okay. Well, I'm going to start off with number one. Okay. The number of milligrams in 6.6 kilograms. Right? We want to end up with units of milligrams. So we need a conversion factor, or maybe more than one conversion factor. In this case, they're in the same system. They're in the SI system. So we should have a way of converting. We can go from kilograms straight to milligrams, or for convenience and for instruction purposes, I'm going to go to grams first. So 1 kilogram is 1,000 grams, right? Okay. That gets rid of the kilograms, leaves us with grams. Now I can get rid of grams and go to milligrams. So how many milligrams in a gram? Well, milli is 1,000th of. So if the unit is 1,000th of, then it takes 1,000 of those to make one of those units. It takes 1,000 of these to make that. Or here's another way you can do it. M stands for milli, 10 to the minus third. So 10 to the minus third grams parallels these two in front of the grams. Okay, you can do it that way. But now we've got grams canceled and we're left with milligrams. Okay, so that's the thinking part. The rest is just number crunching. And so we've got 6.6 times what? Well, we've got 10 to the third times, if the exponent is negative in the denominator and you move it into the numerator, it switches polarity. In other words, it goes from negative to positive. So in the numerator, that would be the same as 10 to the third. No objections? Okay. So that means we have 6.6 times 10 to the 6th milligram is equal to 6.6 kilograms. And that answer would be B. Okay. Better eraser. Let's see if I've got one here. Oh yeah. And it kind of smudges a little bit, but works quicker. All right, number two. Water has a density of 1 gram per milliliter. So the density of water is given as 1 gram per milliliter. Which of these objects will float in water? Right, so we have 3 objects here, and we're given the mass and the volume, which means we have to use our formula. density equals mass divided by volume to determine the density of each one of these. Now, if you're in a hurry on a test, then you need to ask yourself, do I need to know the exact value for each one of these objects in order to answer that question? The question is, will they float? What is the condition that says something will float in water? Compare the densities. The density of an object, if it's less than water, will float. If it's greater than water, it will sink. So if we look at each one of them as object 1, 2, and 3, and we have a mass given for each one, and we have a volume given for each one. Okay, so we have 50, 60.9, 50, 60.9, and the third one is 100. We can't tell just from the mass, right? We have to do the calculation, but we don't necessarily have to do the calculation to its completion. And I'll show you why. 69.4 milliliters versus 54.7 milliliters. And the last one is 40. Okay. Okay. What do we need to know? We need to know the density is either less than, greater than, or equal to 1, which is the density of water. Right? So if we look at this and say 50 divided by 69 is going to be what? Greater than or less than 1? It's less than 1, right? That's almost 70 divided into 50. That means the quotient is going to be less than 1. Right? So this one will float. Now about this one, 60 divided by 54.7. That quotient is going to be greater than 1. That one's going to sink. How about this one? 100 divided by 40. That one's easy. That's greater than 1. It will sink. So the only one that will float is Roman numeral 1. Okay, that's why the answer is B. Did I lose anybody? No? Okay, good. That's the type of approach you need if you're trying to plow your way through an exam in the least amount of time possible. Now, the question had asked for exact values. Sure, you'd have to do the calculation, but to answer the question, we didn't have to go that far. All right, number 3. Convert minus 12.2 degrees C to degrees Fahrenheit. Minus 12.2 degrees C. And we want degrees Fahrenheit. Okay, there's a formula for that. And it should be in the back of your useful information. Let me be sure it's there. Because if it's there, it's supposed to be, yep, there it is. Temperature of Fahrenheit equals 1.8 times temperature of Celsius plus 32. Okay. Now, the way I learned it is degrees Fahrenheit equals 9/5 degrees C plus 32. And that's exactly equal to 1.8. Whichever suits your fancy. All right, so if we plug minus 12.2 in there, and we've learned how to operate our calculator, hopefully. Then I plug this value in here, and 12.2, change the sign, and then add 32. And I get, let's see, 10.0 degrees. Oops, Fahrenheit. Now let's see. We'd still have 3 significant figures here. 32 is an exact number, so we're okay with 3 significant figures here. 10.0 is E, right? Let's scroll down to something unique here. Okay, this one goes backwards in temperature. For this one, we have 232 degrees Fahrenheit. And it wants, well, look at the question. The answers tell you the units that you need. Degrees Celsius, they're all degrees Celsius. So we just use that same formula. Fahrenheit equals 9/5 centigrade plus 32, but we've already got F. So you have two choices. You can put Fahrenheit in here and then solve it for that. Or you can go ahead and solve it for that first, and then insert the value. So if we do that, I'll say 1.8 here. 32, subtract it from this side, leaves that on this side. Now we have C equals F minus 32 over 1.8. And then we can plug in the value of 232. So I get 111.1 degrees C. And since this is not a variable, it's an exact number, it doesn't limit the number of significant figures in our answer, neither does this one. So we can keep all four of those significant figures in our answer. And C would be that answer. Okay, number 9. Which of the following describes a chemical property of gold? We have to know the difference between chemical and physical properties. Remember, property in chemical terms refers to a potential. So a chemical property of gold would describe some potential of gold, and not any changes that would take place, but perhaps signaling the possibility for a change. A says gold is a very dense metal. That's a physical property. Gold is a soft metal. That's a physical property. And we're talking about identity, right? If we want a chemical property, we've got to change the identity or speak to the potential for the change. Gold is an inert, non-reactive metal. That talks about chemistry. Now, gold is not going to change. It's not going to undergo a chemical reaction, but we're describing the chemical potential for gold as non-reactive. D and E, yellow metal, good conductor, heat, electricity, those are physical properties. So you could go process of elimination and find that C was your best answer. Gold is a non-reactive metal. That's why we can find gold just out in the environment. Well, maybe not around here, but in some places we find gold flakes and gold nuggets because it doesn't react, typically. Now we can force it to react, but that's another issue. Number 12. In the sum of 54.34, we're going to add to that 4566. 4566. What's the question? The number of significant figures is in this sum. Okay. Remember the add subtract rule. You can't determine the number of significant figures from the operators, from the beginning numbers. You have to do the calculation. So each one of these has 4 significant figures, but the answer could be different. So we're restricted to that position right there. So we can keep 0, 0, carry 1, another 0, 10. That's 100. This answer has 5 significant figures in it, even though both of our numbers were only 4 significant figures. You might be surprised to know how many students missed that one. because they don't remember the add subtract rule versus the multiply and divide rule. Okay, number 15. Which of the following is an element? Right. All you have to do is know your elements and look for the one that's an element. Alcohol's not an element, salt's not an element, sugar's not an element, vinegar's not an element. Helium is the only element in that list. Right? That's one of the reasons I want you to memorize that list. So you'll be able to recognize elements when you see them. By name or by symbol. All right, number 18. Looks like another unit conversion, only this one's going to be compound. How many liters are in 29 ounces of pop? Okay, we're starting with 29 ounces. And we want to end up with liters. Remember, liters is a capital L. Okay, and we're given conversion factors there. And the reason for that is we're going not only from size of the unit, but systems. We're going from the imperial system or the English system to the metric system. So we're going to have to convert look at our conversion factors. 1 liter equals 1.0567 quarts. Right? That's not quarts. So this has converted to quarts first. So let's do a chained conversion. Ounces on the bottom, quarts on the top. Okay, 32 ounces on the bottom and 1 quart on the top. Now that we've got the ounces out of the way, we can convert systems from quarts, from quarts to liters. And notice that liters is where we want to be. This has to be in the numerator to give us that value. So these cancel. And the numbers we put in there, 1 liter is 1.0567. There we go. So we've done all our thinking. Now we just have to crunch numbers. 29 divided by 32 divided by 1.0567 is, and this is all multiply, divide. So we have 2 significant figures here. We need 2 here. Well, my calculator tells me 1.85762. So how do I round that to 2 significant figures? That's not significant. That's 0. This is significant. So we go 1, 2. So I got to look at this one. That's greater than 5. That means 0.86 liters is my answer. Right. 18. And let's skip down to 20. All right, which of the following is a homogeneous mixture? Okay, this is one of those that is best solved in reverse. When you're trying to find homogeneous mixture, you got to have mixture first. So out of that selection, A through E, which ones are not mixtures? We have A, B, C, D, E. Right? Soil's a mixture. Okay. Pure water is not a mixture. Jar of jelly beans, okay. Copper metal is not a mixture. Right? So we got that one, and the top one, gasoline, that's a mixture. Okay, now we can take these 3, A, C, and E, and look for the one that's homogeneous. All right, if we go from bottom to top, soil is heterogeneous. We covered that in class. Jar of jelly beans, everybody knows that one's heterogeneous. Just look at one and you can see an odd distribution of colors. So gasoline is the only mixture that's homogeneous. Right? That was 20. 22 coming up. Let me get this thing out of my way so I can see what I'm doing. All right, 22. A graduated cylinder contains 20 milliliters of water. An irregularly shaped object is placed in the cylinder and the water level rises to the 31.2 milliliter mark. At this point, what we're saying is, and we have to assume that that object that we're putting in the water does not absorb water and it does not react with water. So whatever it does, it simply displaces water. If the object has a mass of 80.4 grams, what's its density? Well, this is picture time. We got a graduated cylinder. And we start off with 20 milliliters. We got 20 milliliters here. We put an object in it, and the volume rises to 31.2 milliliters. Okay. And the mass of the object is given as 80.4 grams. Okay. So if we're going to solve this problem, mass divided by volume, we got the mass. That's no problem at all. 80.4 grams. Okay. And what's the volume of the thing? It's the volume that was displaced, which is 31.2 minus 20. 11.2 milliliters. Right? So 11.2 milliliters goes here. We've got three significant figures in the numerator and the denominator, so we can keep that number in the answer. 80.4, 11.2 is 7.1. Well, my calculator says 7.17857 grams per milliliter. We can keep three of those, so we're stuck right here. That 8 is bigger than 5, so that means 7.18 grams per milliliter. And that would be A. Okay, scroll again. Come to 25. Another temperature conversion. What Kelvin temperature reading equals 61.2 degrees Fahrenheit? 61.2 degrees Fahrenheit. All right, here's the problem. We don't have a conversion for Fahrenheit directly into Kelvin. We probably could create one because we know the formulas that give us changes in temperature. But for simplicity's sake, we know that to get Kelvin, we take degree C plus 273. Okay? So we have to find out what degree C is. And we know that degree C equals, see, the one I got memorized is F equals C plus 32. And we can put 61.2 equals 9/5 C plus 32. And then we say 61.2 minus 32. And this is 1.8. So we're going to divide this side by 1.8. And that's equal to C. So once we got C, then we can use the other form. 61.2 minus 5. And I can keep three significant figures because that's an exact number and that's an exact number. So I got 16.2. 16.2 degrees C. Now I can put that in here. If I added the 0.15 here, that'd probably be a better idea too. 273.15. So 16.2, 273.15 is rounding to, let's see, one decimal place is 289, excuse me, 289 Okay. Anything come close to that? C. 289.4. Okay. All right. 25. $26. Which of the following processes is a chemical change? Okay, now we're talking not properties, but actually what happens. The potential is now realized for chemical change. So when we look for a chemical change, we look for a change in identity, chemical identity. If you got one substance, after the change, you got a different substance. Dry ice sublimes when left on the demo table. All it's doing is changing from solid carbon dioxide into gaseous carbon dioxide. No change in identity there. B, the light on a candle burns until a bell jar is placed over it for a period of time. That is a chemical change. You're actually combusting wax. Now, in the interest of time, if you're on an exam and you know you've got the right answer and you look down at the other possibilities, right? Sometimes you'll get two of the above, none of the above, all the above, those kind of wonky answers in multiple choice tests. So we've got one down there. E says none of the above processes are chemical change. Well, we found one that was. So we've got our answer. That's why B is the answer. And if you want to, if you got time, you can go to C and D and see that those are both physical changes. So we found our answer as B for number 26. Okay. Let's see, we scroll to number 30. Which metric prefix is used to designate 1/10? Okay. This is just a matter of memorization. Right? We know that 1/10 is deci, which is the abbreviation. The prefix is D. Okay. Those others, big M is mega, like 10 to the 6th times. K, we've done that one before, 10 to the 3rd times, or 1,000. That's kilo. C is centi, or 100th of, or 10 to the -2 times. And then M, milli, is 1,000th of 10 to the -3 times. And the last one in that list is deci. Oh, that's the one we got here. We've already put that one up there. That's our answer. Deci is 1/10. All right, 36. Another unit conversion here. The volume in milliliters occupied by 41.9 grams of mercury. Okay. This goes back to the density of mercury, which is given there. Mass divided by volume. And it's given as 13.6 grams per milliliter. All right, grams comes from this, milliliters comes from that. And the question is, if we're given 41.9 grams, what's the volume? Well, notice we have an equation here in one unknown. Right? We know what this one is. We don't know what that one is. So we just solve for that one. If it's in the denominator on this side, it'd be in the numerator on that side. And the numerator on this side is the denominator on this side. Grams per mil, or 41.9. Okay. So we just need to divide that 41.9 divided by 13.6. is 3 significant figures equals 3.08 milliliters. How do I know that's true? Because numerator, denominator, those cancel. And any unit that's in the denominator of the denominator is the numerator. That's just math. So milliliters comes up here into the numerator, and we have 3.08 milliliters as A is the answer. Right. Moving on, number 40. Okay. We have this number, 004009. Right? How many significant figures are in that number? So here we have to remember our rules. All non-zero numbers are significant. These two definitely are significant. Then we go to zeros. Preceding zeros are not significant. Captive zeros are significant. And trailing zeros are only significant if there is an explicit decimal in the number. So there you go. 1, 2, 3, 4, 5. We have 5 significant figures in that number. All right, 41. The SI prefix that corresponds to the factor 10 to the minus 2. We covered that a couple of questions ago. 10 to the minus 2 times is equal to centi. So the prefix is little c. Oh, well, they got it spelled out. Okay, so centi is A. Okay, 47. The result of the following calculation has how many significant figures? All right, this has a combination of multiply and subtract. So we have to follow our PEMDAS rule. Fortunately, everything has parentheses. All right, so we just do everything that's inside the parentheses first, and then we multiply the rest. So inside the parentheses, we have a calculation of 33.12. Oops, 33.12 degrees C minus 31.12. But they both got 1, 2 on the end, if they do. Okay, so we can go all the way out to the hundreds place. Say 2 from 2 is 0, 1 from 1 is 0, 1's 2, and that's it. So we have a positive 2 degrees C. Okay, now that's going to be multiplied by these others. 0.4333, 4333, and the units on that are joules per gram degree C. That's a complex unit. Grams times degree C is in the denominator, joules is in the numerator. This one's in the numerator, and then 412.1, 412.1 grams. Okay. Now we can fix our units first. This is in the numerator, that's in the denominator. They cancel. That's in the denominator, this is in the numerator, they cancel. So our units are left only joules. Joules is a unit of heat or energy. So now we can multiply them together. 0.4333, 2.00, and 412.1. Actually, we don't even have to go that far. Once we've done this calculation and we found that this has 3 significant figures, this has 4, this has 4, that's the limiting one. We only have 3 significant figures in the answer. I'm thinking like a student taking a test. Quicker you can get the answer, the better. And the question is only how many significant figures. It didn't ask you for the number. the calculation. I just threw that in as for free. All right, 48. What is an example of a homogeneous mixture? All right, here we go again. Mixtures. Which ones of these are mixtures? Well, soil or dust is a mixture. Sodium chloride is a pure substance, right? It doesn't count. Aluminum's pure. Vodka's a mixture. Oily water's a mixture. Which one of those three, soil, vodka, oily water, are homogeneous? We know soil's heterogeneous. Oil and water don't mix, so it can't be homogeneous. Vodka, that's the only one that is a homogeneous mixture, primarily water and ethanol. So D is the answer to 48. It wasn't unique from that earlier question, but there to reinforce, okay? We got a lot of repetition here. We're moving down to 68. All right, a cubic centimeter, cm to the third power, that's a cubic centimeter, is equivalent to what other metric volume unit? Okay. 1 cubic centimeter equals 1 milliliter. I put that in there just to reinforce that conversion. 1 milliliter is 1 cubic centimeter. They're exactly equivalent. All right, 71. The state of matter for an object that has a definite volume, but not a definite shape. All right, what states of matter? Solid, liquid, gas. Let's see, shape, volume. Solids have both definite shape and definite volume. Liquids have indefinite shape and a definite volume. Gases have neither shape or volume. Okay, so the one that has a definite shape and a definite volume and not a definite shape is the liquid. Okay, lots of repetition in there for practice. And then we got one with a picture. Okay. Looks like a beaker, a graduated beaker. 84. You take 20 milliliters of water from a graduated cylinder and add it to the beaker of water below. Actually, to the side. What's the new volume of water in the beaker? Okay, what's the volume of water in the beaker to start with? Right. We're going to take 20.0 milliliters from a graduated cylinder, and we want to add it to what we have there already. So what do we have? Well, we've got a volume between 10 and 20, and it's most likely 15. Right? And remember, there's no line in there for the 5, the halfway between 10 and 20. So this is a guess. This is a guess. This is definite. This is, no, that's not the right word. My mind's gone blank. This is the guess, that's the guess. So when we add them together, we're limited right here. That's a 0, so we get 35. 35 is the correct answer for that addition of one volume to the other. Okay, scroll down to 94. Which of the following is only a physical change? Well, let's see. Leaves turn color in the fall. Well, a change in color implies physical, but why did they change color? They changed color because of chemical reactions taking place in the leaf. So A is a combination of physical and chemical. Only physical. A banana ripens. That's a chemical change. Cookies burn in the oven. That's definitely a chemical change. Sugar dissolves in coffee. That is physical change only. We know that because all we have to do is evaporate the coffee and we get our sugar back. Actually, we get sugar plus some other solids. But the sugar didn't change. Its identity is still sugar and no other process is involved. And E, notice E says at least two of the above exhibit only physical change. No, only one of them does. So E is not right either. Okay. Roll a little bit more. And we pick up 107. A blank is a summary of observed behavior and a blank is an explanation of behavior. If you look at your answers, you find that we're getting at which one of those is a law and which one of those is a theory. A summary of observed behaviors is a law, and an explanation for those behaviors is a theory. So B is the correct answer. All those other combinations in there are meant to confuse you. All right, 114. Your friend is 5 feet, 9.8 inches tall. 5 feet, 9.8 inches tall. Okay. What is your friend's height in meters? All right. Before we can change to meters, we've got to pick a unit, a single unit that we can combine. These two have to be combined into a single unit before we can do the conversion. Otherwise, we have to convert this one into meters, that one into meters, and then add them together. That's another possibility. But I like to clean this up first and then do the conversion. So how many inches is 5 feet? Well, we multiply it by 12. 12 is an exact number, so we got 60, two significant figures, 60 inches here plus 9.8 inches there. We got 69.8 inches. Okay, here's the problem. We can't keep those two significant figures. I mean, this significant figure because that one's not significant. So ideally, we would say 70 with a decimal there to mean that those are two significant figures of inches. And now we can convert to meters, but we need conversion factors and they're not given there. So you have to look them up. And let me be sure that they're in here. Inches. We need to go to the metric system. 1 inch is 2.54 centimeters. 1 inch, which will cancel that, is 2.54 centimeters. Okay. Now we can convert to meters. Centimeters. How many centimeters in a meter? 100. Here we go. So let's see if I get what I'm expecting. 2.54 times and 100 divided. So I get two significant figures. My calculator says 1778, which should be 1.8 meter. That's E. Okay. They're getting more complex as we go. And that's by design. All right, scroll to 116. Which of the following is an incorrect description? Well, let's see. A, B, C, D, and E. What does A say? A homogeneous mixture. Are those two terms compatible? Yeah. Yeah. You can have a homogeneous mixture. So A is okay. A solid element. Oh, yeah. In fact, most of the table is solid elements. Most of the periodic table. A solution of gases. Yeah, it's a homogeneous mixture. I mean, we breathe it every day. Let's see, D, a mixture of solids. Oh, yeah. What's that called? An alloy. Mixture of solids. A heterogeneous compound. Nope. If you've got a compound, that is a pure substance. It's not a mixture. For instance, let's see, glucose. That would be a compound, and it's pure. Now, if it's in your blood plasma, that's a homogeneous mixture. And people with diabetes suffer with problems with that particular compound, having too much of it. I bet most anybody you talk to knows somebody or is related to somebody that has diabetes. I'd be willing to bet. There are very few people that have never met somebody or know somebody that's got diabetes. Okay, 19 is referencing that burette to the right. Okay, so let's put 119 up here and get the question. Using 0 as your reference point, how much liquid has left the burette? All right, so notice this burette, this device, this burette is a long tube with calibration marks on it. And it has a valve, a stopcock in it to control the delivery of a liquid. Now, the numbers you'll notice are backwards. In other words, graduated cylinder starts from 0 to bottom and goes to the top, whatever it happens to be, 100 milliliters, for instance. That's because graduated cylinders are calibrated to contain. So we measure what contains, what's in the graduated cylinder. Burettes are calibrated to deliver. So they start at 0 at the top, and we deliver a certain amount from 0 down to whatever that is. Okay, this particular burette has markings between 20 and 30. That's where we're at. And how many markings does it have? It has 10. So we're saying we subdivided this into tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So that means subdivisions between 20 and 30 would be 1 milliliter, right? So it'd be 21, 22, 23. Notice we read it from top to bottom. 24, 25, 26, 27, 28, 29, 30. Okay, so now that means we have, and I don't know why I can't remember that term. Anybody remember? When you write a number out, you've got all but the last one. The last one is, I hate it when that happens. It's going to bug me if I don't look it up. Two. Four. Certain and uncertain. Okay, so the certain digits in our number are the ones with markings. So the ones position is certain. Right, where are we at? We're down 1, 2, 3, 4, 5. We're right on this one. So that's 22. But we're going to add an uncertain digit so that whoever sees this number doesn't think that we're saying this is uncertain. No, that's uncertain. So that's how much was delivered. Let's see. Oh, oops. There we go. 22.0 milliliters. All right, these are the certain. Let's get that on tape, so to speak. This is uncertain. One of the hazards of growing old. All right. 124. Aluminum has a density of 2.70 grams per cubic centimeter. That seems reasonable. The number and the units. Solids are usually reported in terms of grams per cubic centimeter. Liquids in grams per milliliter. But the numbers are exactly the same, right? Because cubic centimeter and a milliliter are exactly equal in size. Question is, what is the mass of a rectangular block of aluminum measuring 11 centimeters by 22.2 by 34.5? All right, so we have a density equals 2.70 grams per cubic centimeter. And we have dimensions of this cube. Is it a cube? No, it's a rectangular block. So let's say this, that. There we go. The longest side is 34.5 centimeters. Okay. And then we have two short sides. 22.2 centimeters. Let's make this one 22.2 centimeters. And this one is 11.1. Okay, what's the volume of that cube? Because this equals mass per unit volume. And the question is, what's the mass of the rectangular block? Not only that, it's in kilograms. So we've got an added problem. Once we find out what its mass is in grams, we got to convert it to kilograms. All right, so we know the volume of this thing is 34.5 times 22.2 times 11.1. Three significant figures. So three significant figures in our answer. Actually, it would probably be better. You have this problem with calculations. It's called rounding error. If you round at every step of a calculation, then you're likely to get a serious rounding error. Each time you do a step, it rounds up, up, up. And by the time you get to the end, your rounding error is very significant. So when you only have multiply, divide in your calculation, put all the numbers in and do the calculation all the way to the end, and then decide on the number of significant figures, because it just depends on the least number. So if we're going to find the mass equals 2.70 grams per cubic centimeter, right, times the volume. And the volume is determined by 34.5 centimeters times 22.2 centimeters times 11.1 centimeters. There you go. Now we can avoid the rounding error. This is going to be in grams, though. So 2.70, 34.5 times 22.2 times 11.1. And I get 2.2950 times 10 to the 4th grams. All right. Since we're just converting within the metric system, then this would be three significant figures. So if we have times 4, that would be 1, 2, 3, 4. That would move the decimal down to here. This would be 2, 2, 9, 5, 4.0 grams. But we can only have 3 significant figures. So we have 2, let's see, 3 is here. So that would be, raise that to 10, that make this 3, 0. Put that right there. Oh, excuse me. No. Significant figures, we leave these with 0. You know what? It might be better to leave it like this. Because if you change it to standard notation now, it's going to be confusing as to how many significant figures you got left. With this, we can go, let's take that out. Let's go here. 3 significant figures would be 2.30 times 10 to the 4th grams, correct? You just do 3 significance right here. Makes that one 10, carries the 1, and we have 3. Now we can convert it to kilograms. And to the 3rd grams, 1 kilogram. Okay. 10 to the 3rd divided into 10 to the 4th is what? You just subtract the exponents. So that would be 2.30 times 10 to the 1st kilograms. Now, are we in scientific notation? No, we're in, well, one of them is, but that's not the right one. So standard notation here would simply be 23.0 kilograms. And that would be A. Right? I can hear students from my past saying, "Not why. It makes so much sense when I'm sitting in class and you're going through the problems, but when I get home, it just kind of..." That happens if you don't practice. If you practice these types of problems over and over again, you get a familiarity of it. All right. Well, let's see. 132 is another temperature conversion. Why did I put another one in here? We're starting off with a negative degrees Celsius. Okay, I think this one is objective is to be sure that you pay attention to the signs. So F equals 9/5 C plus 32, and we're given C as minus 47.9. Minus 47.9 times 1.8 plus 32. Okay. And we can keep those all significant figures because that's an exact number and that's an exact number. 47.9, change the sign, times, and then 32 plus. So I get 3 significant figures minus 54.2. Degrees. Very good. And that's E. All right. Keep that there. Okay, 133. All right, which one of these does involve no chemical change? When you bake a cake, what happens to that cake? Well, it tends to expand, right? Why does it expand? Because the ingredients you put in there, as you heat them up, make gas. That gas happens to be carbon dioxide from baking powder, right? That's a chemical reaction. So we're looking for no chemical reaction, right? Can't be that one. How about B? Boiling water. Oh, definitely. That's no chemical reaction. Do we have any other options? No, we found the answer. Lighting a match, burning paper, driving a car. those all involve chemical changes, chemical reactions. So we found our answer is B. 134. Copper has a density of 8.96 grams per cubic centimeter. Especially with word problems, I like to extract the information from the problem and put it in a more recognizable form. This is density. It's easier to determine what the question is and how to plot a path if you have the information wrenched from the word problem. Because what's the number one rule of word problems? They are designed to confuse. So we want to get the information from them so that we're not confused. If a cylinder of copper weighing 34.94 grams mass, 34.94 grams, okay, is dropped into a graduated cylinder containing 20 milliliters of water, what will be the new water level? So the initial volume in the graduated cylinder is, say, 20. Okay. When we drop that cylinder of copper in here, the volume is going to rise to some place up here. We don't know what it is. Okay, what will be the new value? Okay, so what caused the movement of that water level? This copper cylinder did it, displacement of water. So the volume of that copper cylinder is equal to this difference, change in volume. Okay. So the change in volume is actually solution solved by this problem. Density equals mass divided by volume. We want volume equal to mass divided by density. Okay. So we know the mass, 34.94 grams. We know the density, 8.96 grams per cubic centimeter. Okay. So we can find out what the density is an exact number. Mass is not. Density is an exact number. So we're limited to 4 significant figures in the answer. 34.94 divided by 8.96 is 3.89954. So we need right here. So that means this is rounded up, and we add that rounds up, and this is 3.900 cubic centimeters, which is equal to 3.900 milliliters. That's our difference, 3.900 milliliters. Okay, so the final volume is going to be that difference plus the original, plus 20.0. Okay, now we have lined up decimals. We're limited to that position. So we can only keep 9 and 3 and 2, 23.9 milliliters. Now that's wrong. Unless oh no, that's not wrong because I left out a 0. My problem here. There we go. That's better. The problem gave us 2 decimal points over here, so I had to add a 2 there. We can keep it here actually. There. 23.90 milliliters is correct. It looks like with all the answers given, I could have got that right even making that mistake. Because if you have no answers that are 2 of the above, none of the above, all those wonky ones, you just have pure answers, then the best answer is 23.90. So when in doubt, pick the best answer in multiple choice questions. All right. Feeling on time. Pretty good. Only used up an hour. We have what, 2 hours? Yeah, we got till 11. Should be able to finish early, actually. All right, get a new marker. It's starting to crap out on me. 137. How many significant figures are in the number? Oh, okay. 4.00700. 4.00700 times 10 to the, actually it doesn't matter, 13. Because this tells us how many significant figures, right? Non-zero numbers, captive zeros, trailing zeros with a decimal. That's 1, 2, 3, 4, 5, 6. 6 significant figures in that number. $138. Okay. Which of the following is not a step in the scientific method? Okay. Well, what are the steps in the scientific method? Usually starts with an observation. See, let's move over here. So you observe something. Better than that. There we go. Start with an observation. And then you create a hypothesis to explain what you saw. And then you devise an experiment to test that hypothesis. Okay. And then I don't think we included evaluate the experiment, but you do. Part of the experiment is to evaluate your information to see if it compares with the hypothesis, and then you circle back. Because you've made new observations in the experiment. Now you're modifying your hypothesis to suit those observations. Okay, which one of these is not change results to agree with your hypothesis? Okay. Believe it or not, some scientists do that. It's called fudging the data. It's called, more than that, it's called cheating. And once you're discovered, your career in the sciences is over. So we don't change the observations to suit our hypothesis. Develop a theory or model. That could be, right? If you went further, right? If you took it further from here to actually here, and you devised a theory with its corresponding model, then you could continue and loop that. Perform an experiment, making observations, formulate a hypothesis. Those are all part of the scientific method. But fudging the results is not. Even if you misinterpret your results, that's not quite as bad as cheating. But if you grossly misinterpret your results to explain, to give you the outcome you want, then that's right on the knife edge. And there have been scientists who do that. Years ago, there was a pair of scientists out of Colorado. I forget which university it was. But they claimed that they had created cold fusion at room temperature on the bench top. And they reported their data. They reported neutron flux. The neutron flux was their evidence for fusion reaction. So they published their work, and other scientists took those experiments and tried to duplicate them, and they couldn't do it. So an insightful experimenter, scientist, tried to explain why they got the results they did. And he looked at all the possible places where you could get introduction of neutron flux, not from the experiment, but from some other source. And he found that that's the problem. They were counting neutron flux coming from their experiment, and it wasn't. So that's the last we ever heard of those guys. I don't know where they are now. Probably flipping burgers at McDonald's. Which is an honorable profession, but it's quite a fall from research scientists down to fast food. 148. An example of a mixture is, okay, we're kind of hung up on mixtures, aren't we? Gold is an element. The air in this room is definitely a mixture. It's a homogeneous mixture of gases, primarily nitrogen, 78% nitrogen, 20% oxygen, almost 1% argon, and then fractional amounts of the others like water vapor, carbon dioxide, and other pollutants. So that's a homogeneous mixture. Purified water is a pure substance. Hydrogen fluoride is a compound. All of these are not mixtures. E cannot be true because B is the only mixture in that group. Right. 149. How many of the following are compounds? Well, let's see. What is a compound? A compound is a unit composed of two or more different elements. So how about these? H2O is a compound. N2O4 is a compound. NaOH is a compound. MnO2 is a compound. HF. They are all compounds. That's 1, 2, 3, 4, 5. A is your answer. They're all compounds. That's another reason I wanted you to start memorizing symbols. If you didn't know what constituted the symbol for an element, then you might be lost trying to figure out which of these is compounds. How many of the following are pure compounds? Following are pure compounds. That's kind of redundant. If you're saying a compound, the compound itself is pure, right? It's only when you mix two or more elements or compounds or combination of those that you get a mixture, and they're not pure anymore, right? So that's redundant. But if we answer the question, how many of the following are compounds? Sodium's not a compound. It's an element. Sugar's a compound, right? Oxygen's an element. Air is a mixture, right? It's not a pure compound. And iron is an element. So there are only two of them in there. Oh, wait a minute. One, let's see. Sodium. Oh, excuse me. Pure compounds. Sugar's a compound. That's it. That's the only compound in there. The rest of them are either elements or mixtures. So B is the correct answer. There's only one compound in that group. Okay. 154. I forgot to write that last one up here. Helium is an example of what? Well, it's an element, right? That was too easy. 156. Which of the following is an element? Well, let's see. Water is a compound. Earth is a mixture. Salt is a compound. Brass is an alloy. It's a mixture. Oxygen is an element. E is the answer for 156. $161. What is the result of the following multiplication expressed in scientific notation to the correct number of significant figures? Okay. So we got 5.46, 10 to the third. 6 times 10 to the third. I think that's right. Yep. And 8.0 times 10 to the minus 3. 8.0 times 10 to the minus 3. We multiply those. Okay, and we want the actual value to the correct number of significant figures. All right, the coefficients tell you the number of significant figures. We can only have 2 in our answer. Okay, so let's split this into 2 calculations. 10 to the minus 3 times 10 to the plus 3 is 1. That's all that's left. 8 times 5.46, let's do this longhand. 0, 6 times 8 is 48. 4 plus 32 is 36. And 3 plus 40 is 43. And that's 3 decimals here. Okay, so we have 43.680 times 10 to the 0, right? That's what that is, 10 to the 0. 3 plus minus 3 is 0. So we got this one, 4.3. Oops, now we have to round it there. So that's 3 rounded up to 4. 4.4 times 10 to the first power, because we moved that decimal 1 place. Okay, I did 2 things at once there. Did that confuse anybody? I moved the decimal to give me my scientific notation, and I rounded the number to 2 significant figures. So C should be the answer, 4.4 times 10 to the first power. These steps in calculations should become second nature to you. The reason I want you to practice all these and just know them, right, when you do calculations, is that when we start doing more complex calculations, you're not going to have time to stop and dither about significant figures. You're going to have to knock them out. So now's the time to practice them over and over until you're bored stiff. Okay, a blank change involves a change in the fundamental components of the substance. A given substance changes into a different substance or substances. That is a chemical change by definition. And we ought to, well, there we are. We're at the end. Okay, were there any of these in here that we skipped over that you would like to take a closer look at? Because we've got plenty of time. Or do you just need to go back and find similar ones and practice? That's probably the case. Yeah, practice, 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 right? Like I said at the very beginning, your 2 best friends are curiosity. You always want to know more, want to know why, want to know more, and boredom. If you're bored working these problems, then you know them pretty well. And that's why I give you so many of them, right? 175 in this first review. There are lots of repetition in here, just so that you get practice and become familiar, comfortable with the procedures.